Today, we're going to deconstruct a concept that sits right at the nexus of architecture, agriculture, and urban strategy. It's called AgriScrapers. Now, let's be clear, this is not merely about indoor farming. What we're really looking at here is a strategic framework for fundamentally redesigning our cities, for resilience and for self-sufficiency. So let's get started. Here it is. This is the core strategic challenge we're facing. The United Nations projects this massive shift, this huge urban migration that's going to place an absolutely unprecedented strain on our traditional food supply chains. The existing model, the one that relies on trekking food over vast distances, it's proven to be more and more fragile.
So the solution? Well, it demands a fundamental shift in how we think about space. Sprawling out horizontally just isn't a viable option anymore. We have to go up. We have to ascend. And this is the central thesis of the urban agricultural revolution.
And that brings us right into our first section. Look, we're not just talking about a new farming technique here. What we're really addressing is a strategic imperative, one that's being driven by the relentless pressures of modern urbanization.
So what exactly is an AgriScraper? Well, you can think of it as a vertically integrated, self-contained agricultural ecosystem. It's engineered from the ground up to maximize food production right inside our dense urban centers. Its primary job? To localize the food supply, which directly cuts down on the inefficiencies and the risks that are just baked in to the current global model.
The real value here becomes crystal clear when you put the two models side by side. Traditional agriculture, as we know, is bumping up against some serious systemic limits. Land is scarce, it's vulnerable to climate shifts, and soil is degrading. The AgriScraper model, on the other hand, offers a targeted solution to each of those problems, essentially turning the liability of urban density into a powerful strategic asset.
All right, let's peel back the layers and deconstruct the core technology. Because if we're going to assess whether this concept is truly viable, we have to have a critical understanding of the engineering and the systems that make it all work. Okay, so the foundation of any AgriScraper really rests on three core soil-free farming methods. You've got hydroponics, aeroponics, and aquaponics. Each one allows for incredibly high-density farming in a totally controlled environment. And they all offer radical gains in efficiency. Aeroponics, for instance, it maximizes how nutrients are delivered while using a bare minimum of water, which is, of course, a critical advantage inside a city. Now, to get those perfect growing conditions all year round, you need a pretty sophisticated suite of environmental systems. We're talking about precision LED lighting, advanced climate control to really push photosynthesis to its limit, and, critically, integrated renewable energy, things like solar panels, to power the whole operation sustainably. A circular economy is absolutely central to the AgriScraper's design. Water, for instance, is treated like the precious resource it is. It's constantly recycled in a closed-loop system that brings in rainwater and even reuses gray water. At the same time, waste is converted right on site. This is all fundamental to making the structure truly self-sufficient. Now, let's really analyze the tangible benefits, and we'll do it through the critical lens of ESG impact, because this is where the strategic value for, say, investors and policymakers becomes incredibly clear. Get this, a 90% reduction in water consumption compared to traditional farming. 90%. In an era where water scarcity is an increasingly dire global issue, that single metric, all by itself, provides a powerful justification for this entire technology. And the efficiency gains when it comes to land use? They're even more dramatic. I mean, leading vertical farms, places like Aero Farms, have already demonstrated up to a 95% reduction in land requirements. This is what validates the concept's ability to unlock agricultural productivity in the very places where land is most scarce and most valuable. But beyond just the resource metrics, the broader strategic impacts are profound. You're talking about a significant reduction in the food system's carbon footprint, the creation of new green jobs, and, perhaps most importantly, a vital increase in urban resilience. An AgriScraper can literally fortify a city's food supply against the kind of supply chain shocks that have become all too common. Of course, no strategic analysis would be complete without a really pragmatic assessment of the obstacles. Credibility demands that we tackle the significant financial and operational hurdles that stand in the way of widespread adoption.
And the primary hurdle, let's be honest, is capital. The initial investment for a large-scale project can easily exceed $100 million. That's a significant capital expenditure, and it demands a very clear and compelling return on investment.
But for each of these key risks, there are potential mitigation strategies. High operational costs? You counter those with renewable energy and automation. The technological complexity? That requires strategic partnerships. Those regulatory and zoning hurdles? That's where public-private collaboration comes in. So you see, for every challenge, there is a corresponding strategic lever to pull. So where is all of this headed? To wrap things up, we're going to position AgriScrapers not as some kind of end goal, but really as a foundational technology for the future. You can see a very clear trajectory here. This whole concept evolved from an academic theory back in the 90s to achieving commercial viability in the 2010s. Right now, we're in the era of early prototypes. So the logical next step is full integration with smart city infrastructure, and then, ultimately, application in extreme environments, both here on Earth and eventually off-world. And that really brings us to the final critical question. We've looked at the strategic imperative, the technology, the benefits, and the risks. So the question now is one of scale and necessity. Are these structures just an ambitious, interesting novelty for future cities? Or are they the essential blueprint for ensuring that our urban populations can feed themselves sustainably and securely well into the next century? That is the strategic question I'll leave you to consider.